my slides are pretty boring. That probably took the longest part of all this, sorry. I finished them off in the car on the way here. So I'll try my best to make it interesting. Yeah, so if you search for that title, you'll probably find a few other people have spoken about it before, in particular a guy called Adi Osmani from Google. I'm not as clever as him. So he's definitely a good reference for this sort of stuff, and I'll quote him in a minute as well. So yeah, my name's Phil Leggetter. I work at a company called Kaplan Systems with Andy there, big hand up Andy. And we're open sourcing a product called BladeRunnerJS. Now Kaplan Systems build large front-end complex applications to license to financial companies, enterprise companies. So BladeRunnerJS really represents a tool that's helped us build these JavaScript applications at scale. So I'll best describe what scale is. So as I said, Adi Osmani is clever than me, so there's no point in me trying to make up my own definition. So he's talking about large-scale JavaScript apps are non-trivial applications requiring significant developer efforts to maintain, where most heavy lifting and data manipulation and display falls to the browser. So we're talking about complex front-end web applications. So what factors affect scaling? So the first one is obviously complexity. And how's this for you? Okay. So most of us know what Gmail looks like, but Gmail is a complex front-end web application. Most of the heavy lifting and data manipulation happens in the browser. What I might do is try and fix that bit. See it better. No, I can't really see it. Anyway, okay, so we'll have to just go over that. So there's a bunch of functionality here. You can see the search bar. We can search for, filter our emails. We've got, unfortunately on the left-hand side, you probably know we've got a bunch of labels, inbox and so on. We've got a whole list of all our emails. We've got tabs, we've got options, or we've got the ability to navigate through our list here. We've got option menus, we've got the ability to compose within the same view. We've got, again, it's off screen, but we've got the ability to drop down and look at contacts, and all this stuff's done on the front end. And then there's our product, which is something called Kaplan Trader, which is actually an SDK. And on top of that, you build these types of applications. So you can just tell by looking at it that we've got grids. This has real-time data coming in. We've got spark lines showing the changing in these prices, these values. We've got candle charts. We've got real-time news coming in. And we've got the ability to execute real-time trades in bunch of different views. We've got the ability to drag this stuff around and change the layouts, save new layouts, and so on. And then menu options and all this sort of stuff. So it's all, you can kind of tell again it's a complex front-end web application. So they're both large single-page apps offering complex functionality and also offering complex interaction, which is important. So there's that from two aspects. There's technology, which is the code within the application is relatively complex and the objects within it are interacting. There's also interactions over the wire, so there might be some sort of services. So there's maybe accessing to back-end services, the complexity in that as well. And then there's user interactions. So because it's a complex application, there's a lot of rich functionality going on in the front end. There's a lot of complex user interactions with that interface. So the second aspect in terms of scaling is size. So no matter how good a developer you are, the bigger an app gets, the more code you have, unfortunately. So how do you go about managing that? So as an example, our SDK, Kaplan Trader, has over 1,000 JavaScript files in it. That's 130,000 lines of code. That includes white space. And around 100 lines per file in there. And then on top of that, we've got tests, 641 files, 95,000 lines of code. We've obviously got a lot of test code in each file. And then on top of this, we create a reference implementation, which was the example I showed before, which is called the FX motif. And that itself is 425 lines of code, 50,000 lines of JavaScript, 200 test files, and 21,000 lines of code in terms of the test files. So that's a lot of code, because there's a lot of functionality there. So the third factor is contributors. So who contributes to this application? So we've actually got a bunch of people. We've got, it might be multiple developers on a team. It might be that there's multiple teams contributing to the same application. It could be that we've obviously got front-end developers, it's a front-end application, but there's also back-end developers who are building services that our front-end app interacts with. There's designers, so designers can be involved at different levels. Some of them do some JavaScript, some of them will just do HTML, CSS. Others will just provide you with assets that you integrate into your application. And then there's QA, and then there's infrastructure. So how do you make it possible for all those people to access and contribute to this application without treading on each other's toes? So I think some of us are lucky that we have teams that have cross disciplines, and we interact with those. All these guys are together. We have designers, developers, back-end developers, and this is a great way of having a team to build this sort of stuff. But not everyone works like that, and certainly within the enterprise organizations we ship our stuff to. They have front-end developer team, back-end developer team, QA team, designer team. I mean, even internally, we've got a UX team, front-end team. But we try and create these teams full of different types of people. So on our team, we've got me, I don't know anything. Andy does a lot of the core Java development. Dom, again, Java development, and we've got QA resource and access to UX as well. So you need to scale your application to account for those three things: for the complexity of the app itself, for the size, all the assets that are involved in that, and for the human factor, the contributors. So what are the causes of scaling problems? Really simple, to be honest. Inconsistency. People do things in different ways. Different people will approach doing problems in different ways. So, I might write code differently to Andy, how Andy writes code, and he's been messing with my plugins recently. He definitely would write code differently to me. And that can cause a potential problem. I might have wrote some functionality, and someone else might come in and go, don't really understand what that does. I want to do this, but I want to do it in this way, and you end up with duplicate effort. So that causes problems because ultimately it's just resulting in unnecessary complexity in your application. And I don't have a great term for this next one. I'm just going to call it overlapping concerns. And what I mean by that is, so if you take a look at the Gmail application, we've got the search bar and a button, and then we've got the composer view and a button. So what happens if I'm going in and I want to just change the styling of my search button, I change the CSS, and all of a sudden it's changed my email send button. Now that shouldn't happen, because I should be focusing on just changing that little thing there. So how do you stop that sort of stuff from happening? And another example might be, say I've written a little string parser for handling my click handler and the search input for searching for emails or contacts. And it's a nice little utility, but it is very much focused on being for that search functionality. But then somebody comes along and they're going to do some filtering on the to input in the composer view for the email, and they see this little bit of functionality, but it's tucked away in terms of this search click handler. But they decide to use it, and then I come along later and I change my functionality there, and it completely breaks that email to input. So we've got to separate those things out. So we avoid all those problems by inversing what the problem is. So inconsistency, we try and keep things consistent across the base. We take complexity and make things as simple as possible. And we go with separation of concerns, which is grouping things together by what they're intended to do. So we avoid those kind of overlapping things where changing CSS in one place affects it in an unintended place. And the same with code. Okay, so how do we do that? We do that through following principles, practices, using libraries, and tooling that helps us do that sort of stuff. So this is what I'm kind of going to go into. The practices and patterns in terms of what we've done are to define a developer workflow that we all follow, define an application architecture, which is the foundation for building our scalable application on, and building developer tools to support that sort of stuff. So we're building BladeRunnerJS plus a bunch of foundation libraries to allow us to build these scalable applications. And obviously that's what we're open sourcing. So the tooling and the libraries, they enable, encourage, and in some cases enforce, because you need to have a set of rules in place and stick by them sometimes. And it's nice to have flexibility, but sometimes things do need to be enforced. These good practices. So the things that I'm going to go into are coding style, code structure, building that maintainable application by providing that foundation, that takes into account both the technology but also the human factor, things like asset structure, and then code quality through testing. So coding style, a really, really simple one. Most of us probably do this already. We're not talking about anything bigger than declarations, statements, naming conventions, and comments. So just maintaining that sort of stuff, so that when someone comes along, looks at the piece of code, they understand. They kind of just look at it, and go, right, I know how this code should look. I know what it does. I'll follow those conventions, so that whenever anyone else comes along, they can understand it in the same way that I can. And that's just done through static code analysis. Unfortunately, JavaScript's a dynamic language, so we just need to analyze the structure of that file. And it can be done through using a tool called JSHint. So we use that, and it can be applied in 3 places. The first one, and probably the best one, is just to use it within your editor of any sort. So you define the style guide, jshint.rc. I can't remember what the file is, but there's a specific file. You just define your rules in there, and then you can integrate it to your editor, and you get real-time feedback as you're typing, syntax errors, or just when you're breaking the rules that have been defined by your team or teams. Then there's workflow integration, so there's just having things like the file watch, and when you save the file, it runs JSHint against it and flags things up. And then there's, in our case, we rebuild our application on F5 when you refresh, so you can flag things up there. And the final one is integration with your build system. So you just have JSHint run against the files there, and obviously if it fails, if the rules aren't met, then you flag up fail the build, and someone has to wear a chicken hat until the build's fixed. So the tooling is really JSHint at the minute. You probably heard of JSLint. That's really Douglas Crockford's set of rules that he would apply. You don't need to go with that. You can define your own. Integration with loads of stuff. They're just links. We've got our own styling guide. Airbnb's JavaScript style guide seems to be quite popular, and it's used by a bunch of other companies. So that's worth looking at. Then there's code structure. So I'm talking about kind of object definitions now. How does your code look, and how's the functionality defined? As most of us know, JavaScript's massively flexible. It's one of the reasons it's very popular, but it's also one of the reasons that you can end up with a lot of inconsistent code and stuff that just does things you don't expect. So how do you get around that? So in our case, we follow a programming paradigm, and all developers write code that's structured in the same way. We define things in the same way. Our functionality is implemented in the same way. And that's all developers across all teams, and we encourage that anybody that takes our customers basically take this code and they build things in the same way as well. So we use classical object-oriented programming. Obviously, JavaScript's a prototypical based language, so we have to do this in our own way. So we've got a library called Topiarist that we've open sourced that allows us to define classes, do inheritance, do interfaces, and everything within our code base is a class or an interface. There is some shim stuff that we chuck in, which adds support for certain browser environments, but I think we'll probably be moving that out as part of the open sourcing process and making that selective. And the great thing about object-oriented programming is most of us probably know what it is, if not everybody. So we understand the concepts. So you go and look at the code, and even if you're not that keen on it, you can still understand exactly what it does, and that is a massive benefit. It's simple. It's a relatively simple idea of object-oriented programming. It's got human factor involved. We're talking about objects and how they interact. Classes should do one thing well, so we're talking about making sure that we've got this single responsibility principle in place. So that's very good. It's making sure that we do have separation of concerns. And although JavaScript doesn't support class at the minute as a type, it will in ECMAScript 6. So the standards people believe that's a good way to go. So that's a good sign. Okay, so this is how we define classes. I don't know who knows Red Dwarf. One person's going to get my jokes. 2, maybe a few. Okay. So in this case, I've got an Arnold Rimmer class, Arnold Julius Rimmer, and the prototype here provides an answer exam paper method or function. So when we create a new instance, and I haven't got it here, but if we call answer exam paper, it will output I am a fish 500 times. And if you know Red Dwarf, he would then do a funny salute and fall over, faint.
I was going to say that you haven't implemented the funny dance.
No, I haven't done that. Yeah,
It's good enough.
Space.
It's good enough.
Was it a dance? Was it not a salute?
It was a salute and the dance. I think it was both of them.
Right.
I haven't watched it.
Okay. Right. So and then we've got inheritance. So here we've got an ace rimmer. Oh. Yeah, we've got an ace rimmer whose name is Ace. He also invokes the constructor for Arnold rimmer. And we extend ace rimmer with Arnold rimmer because obviously ace rimmer is actually an Arnold rimmer but from another dimension. And he overrides the answer exam paper, and instead he answers with something very clever and of course brave. Now interfaces. So here we've got snakehead interface and snakehead's lie. So and we have Arnold rimmer. He of course is a snakehead, so he implements the snakehead interface. And if in the code we didn't define this lie function, when somebody executed it, we'd get an error thrown. Now we actually have a utility function to make this more useful, but obviously he does, and he lies and says he aced his engineering exam. So that's all. These are some basic constructs that we have within our code structure that let us build object-oriented applications. So the benefits of that, as I've kind of said, is that it's widely understood. People know what it is. Object-oriented programming was developed in the 1960s to solve software quality problems that we had. Not that we had, but that they had then. So it was built for this sort of stuff, for developing complex apps. It promotes reusable, maintainable functionality. Each class, as I said, does one thing and supposedly one thing well. And if we use interfaces, we can have we define how you interact with an object, but we don't deal with the implementation. So you can swap out one implementation with another, very simply. So that's the Liskov substitution principle, apparently. But you can see How that's useful. That you can go, actually, the code that I wrote there is rubbish. I'm going to write another version and swap it in, or it might just do something much more efficiently. And I think object-oriented programming, if done properly, it is very simple, consistent, and does promote the separation of concerns. So even if you don't like that, then just make sure that whatever you do is you define a way of, you have a set way of doing this stuff and do it consistently across the board. So if you want to use object.create with a shim for older browsers, then do that sort of thing. So the libraries and tooling that supports this, so as I said, it's not called Tokyo, it's called Tokurist. We changed it recently. There's obviously shims that if you search for object-oriented programming languages, there's a million of them. And a lot of the libraries that people probably use anyway, they generally support these concepts anyway. So, and then in terms of support from tooling, we don't have this yet, but I quite like the idea of what Rails does, that you can generate classes from the command line interface and you can maybe add methods. So there's no reason why you can't add this sort of tooling support for writing JavaScript code. Who's heard of Yeoman? Most people? Quite a few people. So Yeoman have generators for generating applications, but also, I believe, things at smaller levels, like, for instance, if it's Angular services and so on. And also there's something called Loom, which the guys in the Yeoman GitHub issues repository have been discussing as well, so they're worth looking at. I don't have time for this. We've actually got a way of defining our classes in a node style and then including them using require. But if you look at things like comma.js or require.js, that's always very useful for this sort of stuff as well. Okay, so let's talk about the application architecture. We're really talking structure. We're talking about like functional components, pieces of functionality within the app. Application plumbing, so what's the basics we put in place to allow us to build this scalable application? And also, how do you manage the assets? So we had a bunch of goals when we started out. We had we're on Kaplan Trader 3 now. We had Kaplan Trader 2. And Kaplan Trader 2 was kind of creaking in a number of ways. So one of the things we kind of wanted to do was come up with a set of goals and follow them. And I think we basically just looked for some buzz terms in terms of software engineering and went with those. So, but for good reason. So we want separation of concerns. We've got that in terms of object-oriented programming, but how do we apply that sort of thing across the board in terms of both assets, the application structure, so that all these problems that we can potentially see and the different people that contribute to the application don't tread on each other's toes. And we want loose coupling so that the pieces of functionality within the application, they don't necessarily directly reference other things in the app. So I kind of spoke about this earlier, did I? Around, oh yeah, so for instance, if I change, the functionality in my search click handler, that shouldn't really affect anything. The email shouldn't be in any way affected by that. So we want that in our code. So we generally want to be, interface is a really good example. You're interacting with an interface rather than a definition of functionality, so you can sort those things out. So we want a way of achieving loose coupling throughout the application. And high cohesion, another buzzword, it's about grouping functionality together. It's very, comes hand in hand with separation of concerns. You group things together. So in our case, we're talking about keep our assets together. So JavaScript, HTML, CSS, related to that piece of functionality together. Oh yeah, I need to say divide and conquer. So we went, with our tagline, we went divide and conquer complex web applications. And it really is about that. It's about breaking an application down into vertical strips of functionality. So this is the basic architecture that I did in Google Paint earlier. We have components, which are very low-level pieces of functionality, so buttons, input boxes, and so on. You can build composite versions, that contain a bit more. We have blades. Now, blades are an interesting one. I'll go into a bit more detail, but they're basically, they are components, but they're application-specific components. They're like glue code to bring these components together to offer a piece of functionality. And we've got aspects. Now, aspects are different views into your application, and I'll explain that in a minute, but think desktop and mobile views. And then a cross-cutting concern of services that all of these things can access. So a note on how we structure our assets. So normally within a web app, you'll have an assets folder and you'll probably have images, CSS, HTML, JavaScript, or maybe templates for HTML, JavaScript config, and so on, under one folder. And you can imagine, you might have seen it, you get a lot of JavaScript files in there, but you might break it down into subfolders and so on. But again, we want to be doing it so that this is my search input. And I have all the images related to it, the CSS, the HTML, the JavaScript to handle the behavior, the config, maybe some language files, and the tests, all gathered together on disk in the same place. And all those assets, so I guess I've kind of just touched on that, is that we've got a lot of assets. The more functionality you have lots more assets. So you don't really want to be managing, including all those things in your index.html file. So you want a way of ultimately bundling these things together. So our tooling understands the structure of our application. So we can, when we're developing, it handles all that bundling and the serving of these files. And also, a part of deployment, it will take the files for the specific view of the application that we want to see and create a deployed bundle for us. So we kind of call this dependency analysis of our application, so based on requires and links and stuff. And it can give you the details. So what are components? Components are these very small level things. So we've got an input box, we've got a search button. This little drop down thing here might be another component. It might be that the to entry point here is another input. We've got a button, another little drop down. So they're low level components. I should probably say, it could be that we create a component that represents this, that might represent the input box and the search button, because that's quite a common piece of functionality. Ultimately, it's about creating the components are these reusable things, maybe potentially across applications, but at least you might use the same thing multiple times within that same application. So how do we achieve that, and how do we make it stick with separation of concerns? So most people have heard of some sort of, and used probably some sort of MVC solution, because you're separating the data, then the view, and sometimes the controller. In our case, we use MVVM, and we've got a library called Presenter, which is built on Knockout. And MVVM looks like this. We have basically our data, our domain model. It also contains some business functionality. We have a logical view of what the view should actually look like, called the view model, and then the view itself, which will be defined by our templating system and some CSS. So this bit here is all handled by our library, this binding bit here. So we change this, And then this is all handled for us, and the view is generated for us. Okay. So as I said, components are this idea of reusable. They can't contain all their assets associated with them. You can build up more complex components by composition, by using other components within it. And then using something like MVVM obviously allows you to have this separation of concern. So you've just got this view. So an example might be, if it is just the search input, I have a property on my view model which is read-only, and the binding, I've got a template which says, oh, if it's read-only, add a read-only attribute to my input element, and it just handles all that for me. If I set the view model read-only to true, yeah, it will be read-only, and then a user couldn't click on it and so on. And that stuff's all sort of handled for you. So that's the great thing about these libraries. So yeah, the libraries and tools to support this. As I said, we've got something called Presenter. I think the thing that clearly says that this is the way to build applications out of small components is that W3C have got something called web components coming up. You can use it, you can probably use it in something like Chrome Canary by enabling web components and looking at the shadow DOM, which is what it is that actually implements your input elements within the browser anyway. And you can use it now as well using something called Polymer, which is basically a polyfill library. I think Google are doing it, but it's basically exposing these upcoming W3C standards for you to use now in a slightly different way, but ultimately you're building apps as you probably will in the future. And then there are other libraries that focus on building kind of component type stuff. Montage Flight by Twitter, they've used that to build a lot of their front end stuff. That's worth looking at. And then there's, as I say here, the usual suspects that tend to come with some of this component based stuff, but also with a lot more, with routing and various other things. So they're all worth looking at to build things in this sort of way. So blades. So as I said, blades are components, but they're application-specific kind of components that take maybe our reusable components and bind them together, the glue code, to offer this vertical slice of functionality. So in this case, it might be that a blade in Gmail, if we were to write it using our sort of stuff, would be the search input and the input button. It might be this big thing on the side, or it might be the compose view, which actually contains two of these input boxes. This one here searches as soon as you start typing an email address. This is just a simple input. This is an editable HTML area, and then you've got a bunch of buttons down here. This might actually be another blade you want to bring in and maybe make reusable. So that's the idea, that we can break things into this vertical slice of functionality. And it might be that we've got, I should have split this up here. It might be that you have a tab component, and then you also have an email list component, and they might be two separate blades. But I mean, how you structure this stuff is really up to you. It's about breaking them down into functional slices. So blades reference these components in libraries. They're app-specific components. They're unlikely to have a defined API, which I guess is quite important in terms of thinking about it being reusable. So a component which might live in a library has probably got a defined API, and you know how to interact with it. Whereas a blade, you're building your application, you're changing that functionality all the time. So you could just call it like an app component if you really wanted, or it might be that you've used one of these other libraries that it is ultimately, you have these more reusable components in the library, but when you're building your app, you're still building components, but they just change all the time. We've just decided to call them blades. And again, they contain all the JavaScript, HTML, CSS, specific to that functionality and reference the rest of it, the defining components. And they also implement, they're also components which use our MVVM library. And we'll go into why that's important in the code quality bit. Yeah, so as I said, the blades are our specific concept. We've got tooling that lets you create blades and creates the assets for you and gives you a hello world thing. But you can get that probably for other tools as well. So if we look at services, this cross-cutting concern on the right-hand side, they're generally used to access resources, although there are other uses for it, or non-UI tasks. So examples might be a persistent service which connects to a database and stores stuff. A real-time service, I used to work for Pusher, but we also, we also have a lot of real-time stuff. We've got something called the Liberator for streaming data, and we obviously sell to financial clients. So real-time service might be something else, or just a logging service. And a logging service might log to the console, or it might log to a back end. And then services are accessed via something called a service registry. So service registry is basically a dependency injection or inversion of control library. And the best way to explain that, some of you may probably already know, but it's probably just to show how you use it. So services are basically an interface. They're saying this service should offer this interface. And so you know how to interact with that service when you get it. Here I've got a contact service, so it might be that it's used, if you go into your contacts via Gmail, you're searching your contacts, it might use this service. It has a search function, it's got a save function, creating a new contact, and it's maybe got a delete. So that's a pretty simple interface. And then our implementation, I haven't gone into the details of the contents, but it's a RESTful contact service, so obviously it sounds like it's making HTTP requests over the wire when you call one of the methods, save, create, or delete. So what we do is we access our service registry. So this is the way that we include code. It looks very much like Node, it's based on Node, but it runs on the client. We access this service registry. We also access our reference to our definition of this RESTful contact service. And then we can register that service given a name. So we just kind of go, okay, well this is the name we're going to give this service, contact service, and I'm going to provide a new instance of that service in there. So whenever someone accesses it, they get that service. So when I want to use it, so say I'm within a Blade and someone's typed in some code and they've typed in an email address, we get access to the service, a contact service. We maybe search for Arnold Judas Rimmer. We don't like him, so we delete him. Then we might access a contact object that we want to use to save that represents a contact within our contact list, and then we can save it. So we obviously like Christine Kachansky, so we'll save her. Does that make sense? Using that, pretty simple, but that's the good thing. And these services, because we're using these interfaces, they enable this loose coupling. So we don't have definition on real definitions of objects. There's no dependency, sorry, on real definitions of objects. And we're interacting with those interfaces, so we can swap what it is that actually is the implementation behind that. And there isn't any of this, other than when we set up the service registry, there isn't any new my thing going on. And we also use that concept for in-app communication too. So we've got something called an event hub. I've removed the example here because it was quite long-winded and I didn't want to go in too long. So ultimately we've got a service that lets you do message passing between individual components within the application. And in that sense it means that say the tabs, when you click on a tab you change the email list. But maybe, does the tab manager really want to know about the email list? Potentially not. Why doesn't it just go, oh, someone's clicked a tab, and the email list listens for someone's clicked a tab event, and it just goes, oh right, someone's clicked a tab, oh it was the primary tab, it does a search, and it accesses all those emails. So it's a nice loosely coupled way of offering that functionality. And it's a pub-sub message passing, so you subscribe to events on channels, and you publish events on channels. So the tooling and the libraries that enable that for us are the service registry. Spell that wrong? Yeah. Service registry library. We've got an event hub library. AngularJS does have dependency injection. It's optional. Marionette on top of Backbone offers this inversion of control stuff. There's a bunch of other libraries. There'll be micro libraries that offer this that you can just add to existing functionality. And Adi Osmani talks about this as the mediator pattern, the event hub. So that's all worth looking at. So bonus dev tooling. So within our stuff, because we're building vertical slices of functionality with everything required, and because we interact with external things through these services, through these interfaces, we can actually interact with the Blade in isolation, standalone, through services and through poking the view model and seeing how that interacts with the services. So if you remember this view of Kaplan Trader, we've got these little things called trade tiles. Trade tiles? Yeah, trade tiles. And that is a blade. So we can take that out, and this is a slightly different blade, it's a slightly different style one. And we can take it out and we can run it in isolation in these things called workbenches, which are supported by our tooling. And then we can write little tools over here that know how this interacts. So this maybe implements a service, and we've mocked out this service or dummied out this service. And I can click on these buttons and it changes how this functions. and we can have a little output. So this is interacting maybe with a real-time streaming service. So within our code in this workbench, it's a really good development tool. We can just go, right, I'm going to make a fake real-time service. I know the interface I need to define. I know how I interact with this trade tile, and I can just have a for loop or a set timeout that just sends fake data through to my little to my trade tile and changes things. And I can click here and maybe check the output, the log, just to make sure that I have interacted with the service that I expected it to. So this is quite powerful, and if you're building things in this this very modular way, there's no reason why you couldn't take any of these other sets of tools or libraries and build your own little workbench solution. I think it's really, really powerful for the development process, especially if, say, you're a front-end developer and you need that real-time data from Reuters, or you need that real-time, that football score from Opta, but they haven't got around to building that back-end service yet. You go, well, I know how I'm going to be interacting with the back-end service through this service definition. You can chuck your own fake one in there and start building your functionality in the front end. So the final kind of concept in that in the overview was aspects. Now aspects are ways of taking blades and composing the view of all those blades together in a view. So the examples are desktop. It might be that my desktop Gmail view maybe takes a very complicated email list. It probably takes the search bar blade. It'll probably take that email composer view blade and bring that in and reference those. But my mobile view will probably only take the blade that does the search functionality. It will probably take a different blade that implements a simpler email list, and it certainly won't take the blade that implements the composer view. It will probably change it to a simpler composer view for that. So that's what aspects are within our solution. And part of our deployment step, we kind of go, right, deploy for this specific aspect. So it creates a bundle, or it creates multiple access points to get the application with these certain views. We're probably going to have flat file deploy, which will say, right, bundle the application in desktop mode. We get the assets, we deploy them somewhere on a certain URL, then bundle it in mobile view and deploy them on a different URL. And because we've got this dependency analysis, we know which assets to take. So code quality, which is the final thing. Have I been an hour? No, that's all right. I don't waffle on. So we've done a lot of the code quality groundwork by ensuring coding style, by going with code structure, by following object-oriented programming. We do have some sort of modules or package management system to make sure we know how to bring in these files from elsewhere and where to find these assets. We've got an architecture foundation in place based on dividing and conquering, splitting things up in single strips of functionality. We've got services which let us have this loose coupling between the back end and make things very testable. And we've got this event hub for into Blade or into application communication, again in a nice loosely coupled way. And we've taken assets and structured them based on vertical slice of functionality. So we can have one team working on our email list and another team working on the composer view, and they're not going to tread on each other's toes when manipulating these assets and when changing CSS. I know CSS cascades, but we've got a way of bundling where we take the lowest level CSS first, no, last. We take the application CSS, then we take the aspect CSS, then we take the blade CSS, then we take the component CSS. So the lowest level always wins. And we're looking at ways of providing kind of grouping around that as well. I think there's a bunch of different CSS solutions for that. Okay, so we've got asset structure in place, and we can also develop these things in isolation. So all this is making, for a really solid application. But of course, we're going to test it. The best way to ensure a quality application is by testing it. We've got classes, so we're unit testing every single class, obviously. We can test our blades in isolation. We can do that within the workbench, but also a lot of the code that we've probably written to manipulate our blade, we can use that as part of our testing strategy as well. We can update the view model, which isn't the actual view. We're not poking the HTML. We're just changing the view model, and we can check how that affects the interaction with the services. We can implement dummy services and send fake information through the blade from kind of the bottom into the domain model through to the view model and see how that affects the view model. And we can also, if we really want to, run a standard piece of functionality, the composer view or the search input, in a web browser and see how that interacts with mock services. Now we're moving away a little bit from that, but there obviously still is a lot of value in actually poking the UI. And it's all enabled through service registry. So a lot of the times if people tend to run this sort of functionality where we're saying let's run the application in a web browser, we tend to have all our backend services running, we tend to have the full application running. Because we're building our slices of functionality as blades, we don't need the backend, and we've mocked out our services, we don't actually need the backend running, we can just run that single piece of functionality in isolation in a web browser. And we do some full tests just to make sure that certain functionality works and we are interacting with the backend properly. So this is an example of how our testing strategy used to be in Kaplan Trader 2 and how it is in Kaplan Trader 3. I don't know about the terminology, I did this slide, but we used to have a massive suite of Selenium tests, which would require all these backend services to be running, would kick off the application running in a bunch of different web browsers, and automate all these tests. So we'd launch the application in a simple state, in a clean state. We'd execute maybe a little a tile test, close that application down, close the browser down, refresh all the backend stuff, and then kick that off again with another test, maybe testing, dragging tiles around the screen or something. So you can imagine for each of the pieces of functionality, to run the backend application, to have all the services running, to reset all the state used to take forever. So it used to take, and then obviously we've moved to this where we can just test the view model for a lot of tests, and we can test the interaction with services. And if we really need to, we can run the application, have the backend services running, but we don't need to do that. We can focus on testing the interaction of an individual piece of functionality. So it used to take 24 hours and a bunch of virtual machines for us to run this suite of tests, and it now takes 30 minutes, which is a massive win. So the tooling and libraries for this, so we use the presenter library for MVVM, we have the service registry for mocking out these services. We have testing integration through something called JS Test Driver, which is going out of favour a bit at the minute, so we're looking at other solutions. And that, because that's integrated, and we can just point at a directory and say execute all the tests here, it will do that. And we also, any other MVVM library would allow you to do that sort of level of testing. Anything that, if you've done some sort of service registry or some sort of inversion of control, you can obviously swap out those real services for test services, and a bunch of different test runners, and we're looking at Karma at the minute. So in conclusion, hopefully, there's a bunch of benefits to the tooling and the libraries, and hopefully I've demonstrated some of that. The tooling allows us to enforce our coding style. The structure is there through basically following good patterns and practices, but we can also automate the creation of some of these assets in certain ways and in certain locations. We've got a foundation of architecture which is really enabled through libraries, but it might be possible to add some tooling support to that sort of stuff. Asset structure, because we have our command line interface in place, we say create a blade, it makes sure it creates a blade in the correct format and in the correct directory, so we can enforce the assets. Our bundling process means that because we know what these assets are, we can easily bundle them in different ways, and do all sorts of stuff, minification, wrapping them and stuff. So the way that we enable Node.js in the client-side support is by part of the bundling process wraps each class definition in a very small define, a bit like require.js. So we don't actually need to write that require.js part, because why just write code because it's running in a browser? Just write code as it should function and let the tooling handle that sort of stuff. And then code quality, obviously, through again patterns and practices, and we can automate. We've got tooling embedded in our command line interface as well. So finally, hopefully, doing things consistently, making things simple, separating concerns, they're all really beneficial. And complexity ultimately within a complex web application is going to increase. But if you follow these things, then you'll end up with a maintainable front end. We've gone with dividing and conquering by vertical slice. I think web components show that that's the way that we're going to be building web applications anyway, and it certainly helps with scaling. And that the tooling and the libraries are just the glue to enable us to focus on writing code that functions, ensuring quality. Well, we have found, you've seen the size of our application, our code base, the functionality it has, and we've ended up with a front-end application that does scale across multiple teams to large financial organisations, enterprise organisations, and they can focus on just writing features and building maintainable apps. So that's it. Any questions? Did it make sense? Yeah? Is anybody using any of these tools right now? I spoke to guys earlier that were using Grunt. Anyone else using Grunt for some of this task management stuff? Yeah? What about front-end frameworks? What front-end frameworks are popular? Who's using Angular? Quite a few people. Ember? No, Ember doesn't seem very popular at the minute. Backbone? Cool. Okay.
See the testing patterns you have? I use SDN for integration testing.
So we've been having long discussions about what an integration test is. So my feeling about integration testing is that you're talking about potentially integrating with other components. So in our case, you could say that when we run our Blade in isolation in terms of that single piece of functionality, and then we mock out the services, you could say you're testing the integration with your services. They're just not the real services. So we've definitely moved away from having end-to-end integration testing where we're actually testing against the live back-end service, because it just takes so long. We've got good unit test coverage. We've got good functional coverage of each piece of functionality in our app. So we just don't need to do that same level of running the full application and all its services. So yeah, we have.
We kind of had a crossover between integration and acceptance tests. Part of the unit test, we're kind of doing integration tests.
Yeah.
So we've had the same kind of conversation.
Okay. Yeah. I mean, our move has definitely been to use a unit testing solution for as many tests as possible. Anything else? No? All right, thank you very much. Now for some music. Oh yeah.